Let's do this other example in which the resistors in this case are all connected in parallel. Okay. In this case, we have the voltage going in through each resistor, and the voltage drop is gonna be the same all the way through. In this case, the current is the one that changes. Okay. We can find the total resistance. We also have this formula. This applies to both in series and in parallel. So let's just find the total resistance. Okay. So that would be, we actually have to do the reciprocal. So 1 over RT would equal to 1 over 2. So we have 2 ohms. Resistor 2 is 4 ohms. Resistor 3 is 2 ohms. So it's going to be 1/2 plus 1/4 plus 1/2. Okay. Common denominator is 4. Therefore, we have to multiply top and bottom by 2. Top and bottom by 2. So that is going to give me 2/4 plus 1/4 plus 2/4. Once you add all of that, it's going to give you 5/4 ohms. But we're not done. Since this is on denominator, we have to flip this, okay? Because we have 1 over RT equals to 5 over 4 ohms. We want this to be on the top, so we just flip the fractions, which is going to give us a total resistance is equal to 4 over 5. Okay. So then using this formula, V equals IR divided by the resistance, cancels out. So then we get current equals to voltage over resistance. But we know that that's 16 divided by this here, which is 4 over 5, which translates to 16 over 1 and divided by 4 over 5. Since we have a division, we have to do the reciprocal. So 16 over 1 times 4 over 5. And this doesn't look right. Let me see what happened. 5/4, 5/4, reciprocal 4 over 5, 4 over 5. Okay. Oh, I didn't flip the fractions. That's a problem in this case. I left it as it was. So this 4 needs to come over here, and the 4 needs to come to the bottom. So that's going to be 5/4. Okay, this cancels out with that, so I end up with 4. So that means the total current is equal to 20 amps. Okay. So in this case, that means that the total resistance has to be 20 amps. Now let me try this out over here. I know that current is equal to voltage over resistance. So this is going to be it's going to be 16 volts over 2, which is equals to 8 amps. So that's going to be for this one. And then we have the other one, 16 divided by 4, which is 4 amps. Okay, now we can do this one. So 16 divided by 2, which is equal to 8 amps. And then once you add 8 plus 4 plus 8, that is actually 20 amps, which, you know, double check right there. Okay, so that's how you find the total resistance and then the current at each resistor, this being resistor 1, this being resistor 2, and this being resistor 3. Okay.